Imagine a world sculpted from rock and infused with metal, a planet forged in the tumultuous, fiery crucible of our solar system's very birth. This is Mercury, a world of subtle beauty and stark contrasts. It's the innermost planet, the first world in our solar family, huddled incredibly close to the radiant embrace of our sun, and often unfairly overlooked in the grand, cosmic dance of the planets. Mercury swiftly darts through the sun's intense gravitational field, a cosmic ballet, its very existence and characteristics profoundly shaped by its unwavering proximity to this powerhouse of solar energy. To spot Mercury from our vantage point on Earth is often a considerable challenge. It stubbornly never strays too far from the blinding glare of the sun, fleetingly appearing only briefly as a tantalizing morning or evening star in the twilight sky. Ancient astronomers, captivated by its speed, named it after Mercury, the swift-footed messenger of the gods, recognizing and honoring its unique and remarkably rapid journey around our star. But Mercury is far more than just a fleeting point of light in the sky. It's a world defined by staggering contrasts and extremes, a place where temperatures swing wildly, defying our preconceived expectations of what a planet can truly be and how it can behave. It holds invaluable secrets about the very processes of planetary formation, offering crucial clues and insights into the origins and evolution of terrestrial worlds, including our own Earth. Our quest to unravel the mysteries of Mercury began with the first telescopes, and now continues with the tireless efforts of advanced robotic explorers sent to its harsh environment. Mercury is definitively not just another inert rock floating in the vastness of space. It's a unique and invaluable laboratory for studying extreme physics under intense conditions, and a well-preserved museum showcasing the long and complex history of planetary evolution. So, let's embark together on an extraordinary journey inward, venturing past the familiar worlds of Mars, our own Earth, and scorching Venus, feeling the sun's radiant energy intensify dramatically as we draw ever closer, as we finally approach this enigmatic and intensely scorched world. Mercury, in its stark beauty, has bravely endured billions of years, withstanding the relentless assault of harsh solar radiation and constant cosmic bombardment. It holds the potential to teach us profound and fundamental lessons about planetary resilience, the intricate processes of formation, and the universal laws that govern our cosmos. Come with me, won't you? Let's embark on an unforgettable journey to explore the captivating planet Mercury. Imagine a world defined by its proximity to a star. Life as the closest planet to the sun means living with extremes, a constant battle against the elements. It's a place where the very definition of habitable is challenged. Mercury orbits just 36 million miles from the sun, a mere fraction of the distance we are from our star. That's less than half Earth's distance. A journey to Mercury would be a relatively short trip in cosmic terms. From its surface, the sun looms 3 times larger, dominating the sky with its immense presence. And it's 7 times brighter than from Earth. The intensity of the light is almost unimaginable. Sunlight here is so intense it can melt lead, a testament to the raw power of the nearby star. This creates temperatures that soar to 800 degrees Fahrenheit, 430 degrees Celsius, during the day, a scorching inferno under the constant bombardment of solar radiation. Any water or organic material would be instantly vaporized, leaving behind a dry, barren landscape. With no real atmosphere to distribute heat, the planet is left vulnerable to the sun's harsh rays. The day side is scorched, a landscape of baked rock and unrelenting heat, while the night side plunges to minus 290 degrees Fahrenheit, minus 180 degrees Celsius, a frigid wasteland of frozen shadows. That's a temperature swing of over 1,000 degrees, a dramatic shift that occurs within a single rotation. It's the most extreme temperature range in the solar system, a testament to the planet's unforgiving environment. Mercury is both hotter than a pizza oven, capable of melting metal in an instant, and colder than liquid nitrogen, a substance so cold it can freeze almost anything on contact. All this happens in a single day-night cycle, a constant flux between fire and ice. This duality of fire, this intense heat that bakes the surface, and ice makes Mercury truly alien, a world unlike any other in our solar system. Spacecraft sent here need advanced shielding, layers of protection to withstand the extreme temperatures. They must be built to survive these extremes, a true test of engineering ingenuity. Understanding Mercury's temperature swings, mapping the thermal landscape of the planet, reveals its composition and history, providing clues to its formation and evolution. the lack of atmosphere shapes its environment, leaving the surface exposed to the full force of the sun and the vacuum of space. This challenges our engineering, pushing the boundaries of what's possible in spacecraft design and materials science. Mercury's extremes are a window into the powerful forces at play near our sun, a glimpse into the raw energy that shapes our solar system. Stand on Mercury and you'll see a landscape scarred by billions of years of impacts. Its cratered surface, like our moons, preserves a record of the solar system's violent youth. The Caloris Basin, nearly 1,000 miles across, was formed by a colossal impact that sent seismic waves around the planet. On the opposite side, these waves created the bizarre, weird terrain. Mercury's surface also features long cliffs or scarps, some stretching hundreds of miles and rising over a mile high. These aren't from tectonic plates but from the planet's core cooling and shrinking, wrinkling the crust. Mercury is, quite literally, a shrinking planet. Its craters and scarps make it a geological museum, preserving clues to its past. By studying crater density, we learn about the frequency of ancient impacts. The great scarps reveal how Mercury has cooled and changed internally. Mercury's surface is a dynamic history book, written in rock and impact. It invites us to read its incredible story. Mercury doesn't have a true atmosphere, just a thin exosphere, a ghostly envelope of particles. Its pressure is less than 1/1,000,000th of Earth's, making Mercury nearly a vacuum. The exosphere is constantly blasted away by solar wind and radiation, but also replenished by micrometeoroids and solar particles. Sunlight can even knock atoms off the surface in a process called sputtering. This creates a delicate balance between loss and replenishment. The exosphere's composition, oxygen, sodium, hydrogen, helium, potassium, reflects Mercury's surface. Studying it lets us analyze the planet's crust from afar. Sodium and potassium levels change with Mercury's orbit, revealing how the solar wind interacts with the surface. The lack of atmosphere causes Mercury's extreme temperature swings and leaves its sky pitch black, even in daylight. You could see stars while standing under the blazing sun. Mercury's airless environment is stark and silent, stripped bare to the harshness of space. It's one of the most alien landscapes imaginable. Here, the planet is exposed directly to the sun's fury. Time on Mercury is unlike anywhere else in our solar system. It presents a truly unique and fascinating case study in planetary motion and temporal perception. A year here, one complete orbit around the sun, lasts just 88 Earth days. A relatively short duration when compared to other planets. But a day, the time it takes from one sunrise to the next, stretches to an incredible 176 Earth days. It's an experience of prolonged sunlight. That means a single day on Mercury is twice as long as its year, a truly bizarre temporal phenomenon. This is due to a spin-orbit resonance, a celestial dance orchestrated by gravity. For every 2 orbits it makes around the sun, Mercury rotates exactly 3 times on its axis. The sun would rise, crawl slowly across the sky, pause in its track, and even appear to move backward for a time, before resuming its eastward path. A celestial spectacle, a bizarre dance unique to Mercury. The long day allows the surface to heat up to extremes, reaching scorching temperatures, while the equally long night brings a deep freeze, plunging the planet into frigid conditions. This strange clockwork is the result of the sun's immense gravity, relentlessly tugging on Mercury over billions of years, shaping its rotation. The planet's relatively slow spin and comparatively fast orbit create a cosmic rhythm far beyond our everyday experience, a celestial ballet. Understanding this unique timing is key to understanding Mercury's extreme environment. The extended periods of daylight and darkness are the primary drivers of its wild and dramatic temperature swings. Mercury's dance with the sun is a beautiful and compelling example of cosmic physics at work. It's a world where time itself seems to be twisted and warped by the immense power of gravity. For years, scientists thought Mercury was bone dry, a furnace too hot for ice. But Mercury holds a paradox: water ice exists here, hidden in permanent shadow. The planet's axis is barely tilted, so deep craters at the poles never see sunlight. These shadowed craters are among the coldest places in the solar system where ice can survive for billions of years. Radar from Earth first hinted at ice in the 1990s, but NASA's Messenger spacecraft confirmed it. The discovery changed our understanding of Mercury and showed that even the harshest worlds can harbor pockets of stability. It suggests water, a key ingredient for life, may be more widespread in the solar system than we thought. Mercury, the planet of fire, is also a planet of ice, a beautiful contradiction. It reminds us to expect the unexpected in our search for cosmic wonders. For centuries, Mercury was just a mysterious point of light. That changed in the 1970s with Mariner 10, the first spacecraft to visit Mercury. The mission used a gravity assist from Venus, a pioneering technique, to reach the innermost planet. Mariner 10 made 3 close flybys mapping about 45% of Mercury's surface. The images revealed a world like our moon. Ancient, gray, and cratered. We saw the giant Caloris Basin and mysterious scarps for the first time. Mariner 10 also discovered Mercury's strong magnetic field, hinting at a large molten iron core. It measured the exosphere and extreme surface temperatures. Mariner 10 was our first reconnaissance, raising new questions and paving the way for future missions. It transformed Mercury from a distant mystery into a world worth exploring. Decades after Mariner 10, the Messenger spacecraft entered Mercury's orbit in 2011. Instead of brief flybys, Messenger spent years as Mercury's first artificial satellite. The journey was complex, requiring multiple gravity assists and nearly 7 years to arrive. Once in orbit, Messenger mapped the entire surface in high resolution, revealing what Mariner 10 missed. It confirmed water ice at the poles and found high amounts of volatile elements, challenging our theories of Mercury's formation. Messenger measured the planet's magnetic field, discovering its offset toward the North Pole. The mission lasted over 4 years, sending back a treasure trove of data. In 2015, Messenger ended with a planned crash, leaving a final mark on Mercury's surface. Messenger transformed Mercury from a point of light into a complex, fascinating world. Why study Mercury? A small, hot, airless rock. Because it's a key to understanding our solar system. Mercury is a cosmic Rosetta Stone, helping us decipher how rocky planets form. Its enormous iron core, thin mantle, volatile-rich surface and magnetic field challenge our models of planet formation. Did a giant impact strip away its crust, or did the sun's heat vaporize its outer layers? Studying Mercury refines our understanding of these processes. Mercury also helps us study the sun's effects on planets, acting as a natural probe for space weather and plasma physics. These lessons have direct impacts on Earth, from satellites to power grids. Exploring Mercury is part of our quest for context, understanding our place in the universe. We must look outward to our planetary siblings to see the diversity and quirks of our cosmic family. Mercury, the swift messenger, carries a profound message from the dawn of the solar system. It reminds us that the cosmos is full of mysteries, waiting for curious minds to explore.